Hello, everybody. Good to have you here. If you happen to be joining on the live stream, if you're watching the recording, thanks for being here as well. My name is Brian Redmond. I am a product manager on our Azure Kubernetes service team here at Microsoft. I typically will be the host of these sessions. So as always, I will kind of join for these and sometimes do a little bit of announcements at first. But typically the goal is to kind of have a special guest to talk about some kind of technology and so forth. So thanks for being here. I see a couple people saying hello. So hello, folks out there. One thing I actually wanted to start with first is a video that actually was just announced. So let me actually jump over to that. I'll put the link to this out in the chat. This is basically a pretty simple kind of walkthrough on how to deliver a more OpenAI type intelligent app onto Azure Kubernetes service. Paul Yu is one of our colleagues that works in our cloud advocacy team here at Microsoft, and we actually together worked on this this demo where basically it's a very simplistic microservices example. And the scenario is, let's add generative AI technology to an existing application. And so the fake scenario is you've got a retail company and they're adding products, and we're going to use OpenAI's text models to actually generate these descriptions. And so it kind of walks you through that process. The video is really good. It'll point you towards the repository where the source code is and so forth. So I encourage you to try it out. It's a pretty simple kind of walkthrough. The scenario is meant to be simple to get you started, but immediately you'll start to see, okay, well, I wouldn't put my keys in a YAML file. I would use things like workload identity. And so those are the right questions, and we kind of have those examples for customers as well to kind of show how to do it in a secure way. So again, I'll put those links in the chat in a moment, but certainly good to go take a look at that. So as far as the community meeting today, I'm going to kind of jump right in. I don't have really a whole lot of announcements. My goal is to kind of do a couple of these a month at least. And so in some cases, we'll always have a cadence where there'll be a lot of interesting kind of announcements and so forth. We just did this a couple of weeks ago. Everybody's working really hard, but no announcements at the moment. So we're going to jump right into our community topic today. And I'm going to welcome in Bhavin Shah from Portworx. So let me get Bhavin added. Hey, Bhavin, how are you?
Hey, Brian. I'm doing great. How are you? Thank you for having me on the AKS community stream.
Yeah, good. Let's have you do a quick introduction. Tell us kind of what you do for Portworx, and maybe an interesting fact about yourself.
Yeah, for sure. I guess that's this last question threw me off. But I'm Bhavin Shah, part of the product management and technical marketing teams at Portworx by Pure Storage. I've been working with and around Kubernetes for the past 3 years or more than that at this point. Don't remember, or to be honest. One interesting fact, I know we were just chatting about this. I also co-host a Kubernetes podcast called Kubernetes Bytes. So if you want to hear more from me and my co-host when we interview guests from the community, join us and subscribe to that podcast.
Yeah.
Sorry for that shameless plug. You threw me off, and I didn't have anything else interesting going on.
It's perfect. We'll put a link into the chat about it. Absolutely.
Awesome.
Yeah, and I think this is a topic I really wanted to make sure we covered. In my opinion, the use of persistent workloads on Kubernetes has been almost controversial at times. There's a lot of folks that feel that it's just not intended, for Kubernetes. That why would you do that? And I tend to disagree. I think there's the right kinds of workloads that persistent storage really makes sense, and I'm sure you feel the same way. But obviously building a full database engine and running it in a Kubernetes cluster, maybe isn't the ideal scenario. But there's so many other kind of scenarios where people are running Redis caching solutions, and they need that close to the code, and they still want to have replicas and persistence to it, but it's not the only copy of that data. It eventually persists somewhere else, perhaps in a cloud storage kind of model. So I'm more and more hearing scenarios around it. It's also around machine learning. A lot of things around machine learning are temporarily happening in the Kubernetes cluster. And we often need really performance storage for those kind of workloads as well. So I'm going to give you a chance to kind of talk about what the great things you're doing with Portworx and Azure Kubernetes Service. So I'm going to turn
Yeah,
it over to
sure.
you, and I'm going to add your slides here and let you go to it. But yeah, thanks again for being here.
Awesome. Thank you so much, Brian. And just to continue your thought, right? I think when Kubernetes started, right? Like I don't know, at this point, like 8 years old, it wasn't meant for stateful applications. Yes, that's a true statement. But then, as Kubernetes has evolved, as the CSI standard has evolved, as constructs inside Kubernetes have evolved, right? Because like people have started using stateful applications, or are now more comfortable running stateful applications in Kubernetes. We have so many customers that are doing this in production, which gives us the confidence like, okay, this is doable. And that's what we are here to talk about, right? Like there is value in running stateful applications or even databases on Kubernetes. So let's start the presentation like with that topic. Like let's talk about the benefits of running databases or data on Kubernetes. And when I say data, I don't specifically mean like a PostgreSQL or a SQL Server instance. It can be any application, right, that want to persist data. Like as we all know, pods are ephemeral in nature. They can go away if a node reboots or if the pod itself goes down. You want your data to persist across these pod life cycles, and that's where having an object like persistent volume claim inside Kubernetes helps you store all of that data. So talking about benefits, the first one being scalability, right? Imagine doing this on premises or doing it on VMs running in the cloud. You might, if you have a database cluster, and if you want to scale the cluster, you might have to deploy a new VM instance. You might have to install everything, all the binaries on it, add it to the database cluster. And that takes some time. Like you can automate most of these things, but it still takes a lot of time. For people that are already familiar with Kubernetes, we all know that just scaling things in Kubernetes is super simple. Let's say I'm running a Cassandra ring or a Cassandra cluster on AKS. And I started with a 5-node Cassandra cluster. I want to scale it up to like 10 nodes. All I have to do is just go to that deployment object, increase the number of replicas that are configured, and Kubernetes will do all the work for me. I don't have to worry about installing or deploying anything. I just tell it like I need 5 more clusters. I want to scale up. And it will go ahead and match and use that reconciliation loop and match the desired state to the current state of inside my AKS cluster. Talking about the second thing, unified management. If you are already running your applications as containers in Kubernetes, it makes sense to also have the stateful components of those applications inside Kubernetes as well. It just reduces the amount of operational overhead that your teams might have. So you don't have to worry about managing 2 sets of user interfaces or 2 sets of APIs to manage your front end or ephemeral components of your application and the databases of component of your application as well. Next point being consistency, right? And we all know this just as a Kubernetes benefit, but it also applies when you're talking about running data on Kubernetes. Let's say I'm a developer, I want to use Postgres for the microservice that I'm working on. I can create a simple YAML file that deploys that on my laptop. I can have a local instance running of it. And then when I want to promote it through my dev environment, through staging to production, I can just use the same YAML file or same components and move it across different stages in my application or software development lifecycle. That's where the consistency part really helps. Like I know this may sound repetitive to the audience here, but with the value prop of containers, where I can define the specific versions and include all the dependencies that a specific component needs inside a container image, that applies to like running databases on Kubernetes as well. Talking about easy maintenance, let's say I want to upgrade my version of PostgreSQL, right? Instead of having to schedule like change block windows and things like that, I can still just use simple Kubernetes concepts like deployment objects or the stateful set objects. Just tell it, okay, I need to upgrade from, say, MySQL version or Postgres version 14.1 to 14.4. And Kubernetes takes over and non-disruptively, based on your on the pod disruption budget that you have configured, goes ahead and upgrades that version of Postgres. So easy maintenance, making sure like you can control what's running. You can also control. You don't have to manually make sure you have enough instances of your database nodes running. All of that can be handled by Kubernetes. Improved security. I know you, Brian, you did an episode around Istio, right? If you have service meshes, or if you want to, you just use Kubernetes network policies, you can use those policies and apply or enforce these rules to ensure that only specific components or specific applications can access your database that's running inside Kubernetes. And all the traffic is just internal to Kubernetes, right? It's not going outside to an availability zone or a region or a VNet and coming back, and you have to worry about securing multiple points. We just want to reduce the attack surface as much as we can, and having everything inside the same Kubernetes cluster will definitely help there. And then if you have new CVEs, right, a new CVE pops up, there's a fix available. All you need to do is just go ahead and apply that or patch that image, and you'll have a new version which doesn't have that vulnerability in that version. So that's easy to do and easy deployment. The reason it's last is because all I need to do, like YAML is difficult, but then once you have figured out how YAML works and how to configure different things, Kubernetes has the concept of operators and custom resources. So each major database out there, even products like Portworx, have an operator and a custom resource that can be easily used to install and manage or update the product or the solution that you have running on Kubernetes. So these are some of the few benefits. If people have questions, feel free to like put it on the YouTube chat. We'll definitely answer those and as we go on. But when we are talking about running data on Kubernetes, right? I know I said like in 2015 or 2017, Kubernetes was not built for storage and data management. There have been improvements, but there are still certain things that we need to add to Kubernetes to make sure that users have a good experience running databases or data on Kubernetes. And as we all know, Kubernetes doesn't really solve the data problem. It solves the orchestration problem and acts as that unified orchestration layer across different platforms. It still misses out on things like having a unified solution for data encryption and security. Like if I'm running something in AKS, I might have a different security or encryption at rest solution. If I'm running an Azure Arc enabled cluster on my on-premises Azure Stack HCI environment, I might not get the same encryption at rest feature in my hybrid cloud environment. And this is where a solution like Portworx can help. What about disaster recovery, right? Kubernetes doesn't really have an answer for disaster recovery. How can I take my applications that are running on my primary cluster, fail them over to a secondary cluster, and make sure my application comes back online in an event of a disaster? That's where, again, Portworx can help users as well. And then backup and recovery, right? It's no longer enough to, like Kubernetes, even though it has come along and now supports volume snapshots, they are still running on the same AKS cluster. So if you lose your cluster, like we all know, snapshots are not backup, so you lose your snapshots as well. You need a solution that can help you back up and protect your applications that are running on Kubernetes. So these are some of the challenges that we'll talk about, how Portworx solves these challenges in the remaining of this presentation. And then we also have a demo that talks about where we walk through a few of these features. Okay, so introducing Portworx. Portworx has consistently been recognized as the #1 Kubernetes data platform. This is not like this is a marketing slide, but this is not just a marketing slide, right? This allows you to I have quotes from analysts that will support this claim, but it has been the #1 platform for 4 years in a row. It is the gold standard of Kubernetes storage when you talk about running stateful applications or running databases on Kubernetes. So what we are here to talk about is how we can support AKS, right? So if you're running that hybrid cloud environment or that Azure Arc enabled environment, or if you're running AKS clusters in any region, Portworx can basically run on top of your AKS cluster itself. So Portworx is a cloud native storage solution. So you don't need to buy like a storage array. You don't need to buy like a storage array equivalent in the public cloud. You can just use a storage solution that runs on your Kubernetes clusters itself and gives you all the capabilities you need to have a good experience. So data storage is that primary bucket when it comes to Portworx. So it's a product called Portworx Enterprise, cloud native storage solution, which runs on AKS and gives you a unified storage pool that you can use to consume read-write once and read-write many persistent volumes. So you don't have to worry about configuring different CSI plugins for different kinds of volumes that your applications or your developers might need. Talking about the second bucket around data protection, this is where we have a solution that is, again, Kubernetes native, can help you take inventory of all your applications that are running on your AKS cluster and show that to you as, based on the different namespaces that you have deployed in. And then you can create these backup jobs where you can take an application that's running on AKS and store a backup snapshot, which is an end-to-end application consistent snapshot in an Azure Blob Storage repository. So you can take application snapshots based on namespaces, based on specific labels, based on specific resource types. You can customize it however you want. And this is where having that self-service capability so that even a developer can take backups, or your DevOps admin or a platform engineer or a backup admin can take backups of all the application will definitely help. And then the final component is being database ready. And this is like Portworx has been around for years, right? I think they started along the same time when Kubernetes did. So we have helped customers for half a decade. And as we saw customers adopting Kubernetes more and more, we identified a need of making it easier for them to deploy databases on Kubernetes. And that's where our third product called Portworx Data Services comes into the picture, where it's a hosted control plane from Portworx. It's a database platform as a service where we have a curated list of database images that you can use to deploy any database, including things like SQL Server, on an AKS cluster or any other Kubernetes distribution that you might want. So that's just a quick overview of what Portworx does. And as I promised, here's the latest Gigam report that came out, I think, last month, where they identify us as that enterprise-grade solution that's needed for running databases or data on Kubernetes. They do call us out as gold standard, and that's always good to hear, like gold standard in Kubernetes storage for the enterprise. So a screenshot if people want some data to back my claim up. Okay, so just a couple more slides, right? I won't bore you with more slides. We'll jump to a demo really quick. But I wanted to talk about different use cases or challenges that we solve. So starting with the first on the top left, software-defined storage layer, right? This is where, being that Kubernetes native, being easy to deploy using things like the Portworx operator and a custom resource, we allow developers or administrators to provision container granular persistent volumes. So all the administrator needs to do is they can create a range of different storage classes that can be completely customized. And these customizations include things like setting the replication factor. How many replicas do I want spread across my AKS cluster? Setting a specific snapshot schedule. Do I want the snapshot to be hosted on or to be stored on the same AKS cluster, or I want it offloaded to a blob storage account as well? Do I want to enforce QoS policies that I don't face like noisy neighbor issues? I can control the maximum read and write IOPS from day zero inside that storage class definition itself. So Portworx allows you to customize all of those things. Next, it helps you migrate your applications back and forth as well. You can take an application that's running in AKS, move it to Azure Arc, enable Kubernetes, or vice versa as well. You don't have to when I talk to people at trade shows, right? One question or one response I always get is, I can just take my YAML files and deploy it again, right? That's true, but if you have actual data or if you're running stateful applications, deploying the same YAML files will just give you a second instance of Postgres. It won't make sure that you have all of your data that you had created or generated at one site and migrated it to other. That's where Portworx can come in and help. Lower risk with automated protection. This is where we have things like role-based access control. We have data at rest encryption as well, where you can either have encrypted volumes and using a single private key across your entire AKS cluster, or if you're running a multi-tenant AKS cluster, you can take or you can configure individual keys, use your own KMS systems, and then encrypt persistent volumes on a multi-tenant Kubernetes or AKS cluster. Next one, talking about high availability and replication. This is something that I really like, right? I personally like. Portworx gives you the ability to avoid single point of failures at different levels, starting with just the cluster level. If a node goes down, how does your data get moved to a different node? This is where having replication built into the Portworx tier allows you to have replicas that are ready to take over if a node or a specific availability zone goes down. Let's say we want to go to the next level, like, oh, what if my entire AKS cluster goes down? If it's in the same region, you can use Portworx to create a synchronous disaster recovery solution where you have applications running on your primary cluster and you have a secondary cluster running in the same region. If your primary cluster for any reason goes down or is unavailable, you can recover all of your applications on your secondary cluster with zero RPO or zero data loss, with just a few seconds to minutes of our RT or recovery time objective. And then if you want to build that cross-region architecture, maybe I want to take something that's running in US East and take it to Europe West, I can create an async disaster recovery solution as well, where every 15 minutes, that's the lowest, you can configure your own SLAs or schedules. You can take your applications and incrementally copy them to the secondary site. So you have a copy of your application running. So different tiers of resiliency that Portworx can provide if you're running it on AKS. Talking about the next one, auto scale storage as your app grows to reduce costs. So this is where our Portworx Autopilot feature comes in. And again, we didn't decide this name after the whole Copilot or Gen AI thing. This has been a feature that has been around for a while, and it allows you to it's a rule-based engine, right? It allows you to set policies or rules in place where if your utilization on a specific persistent volume exceeds a certain threshold, Portworx will automatically perform an action that you tell us to. So it's a simple YAML file. Let's say I want to, if my volume gets more than 50% full, I want Portworx to add 50 more gigs of storage. And I apply this rule against all the different PVCs running in a specific namespace or based on specific labels. And Portworx can automatically monitor those using Prometheus and then perform those expansion operations. So you won't have to worry about getting paged at 2 a.m. in the morning and having to expand your persistent volumes because they're getting full and your application might go offline. And then finally, maintain compliance and governance. This is where having that backup capability will help. Portworx follows the industry standard of 3-to-1 backups, like 3 copies of data, 2 different locations, one of them being offsite. You can use those for your Kubernetes applications as well. So just 3 different case studies I wanted to highlight. T-Mobile, one of our public customers, whenever they have a new iPhone launch event coming up, they had to plan for it way in advance. They had to make sure everything was tested, and then the deployment time was like 6 months to get changes in place. Now with Portworx and moving to containers, they are now able to iterate much faster and get new deployments or reduce the deployment time to a few hours instead of a few months. Operate at massive scale. So RBC, another one of our public references, do use our disaster recovery solution for their mission critical or tier 1 applications. They didn't want to push anything to production without that application having a disaster recovery plan or a DR plan. This is where Portworx helped them as well to create a 0 RPO solution. And then finally, reduce storage cost using the Portworx Autopilot solution with the policies in place. You don't have to over provision storage and pay for everything. From day 0, you can set policies in place and scale as your application needs more storage, and that's where you basically end up paying money. So it helps you save on cloud storage costs as well. So that's the business value. Let's switch to a demo, and then we can also I can share how you can get started if you like some of this this story. So I wasn't brave enough, Brian, and I didn't go with a live demo. I just wanted to make sure everything works. So we have a quick 10-minute demo around how Portworx works with AKS. So let me just play that, and I can talk through it. So here we have a simple AKS cluster, a 3-node cluster running in US East, running Kubernetes version 1.26.6. I've already installed Portworx Enterprise, 3 AKS worker nodes. That's where Portworx is running. So it's a 3-node Portworx storage cluster. And then Portworx has a feature called Cloud Drives, where once you tell it how much storage you need, it will automatically talk to the Azure APIs, provision those Azure disks, attach it to the worker nodes, and aggregate them into a unified storage pool that can be used for block and file-based persistent volumes. So you can see a quick status of the Portworx storage cluster. You see the same 3 nodes, but each of them contributing 150 gigs of storage to the unified storage pool, which is 450 gigs. So since it's 3 nodes, you can deploy PVC and have its replica spread across different nodes in the cluster. So let's create 2 different storage classes. The first one for read-write once or block volumes with a replication factor of 3. So any volume that you deploy will be spread across all 3 nodes in your AKS cluster. And then a read-write many of a storage class with a replication factor of 2, where it will have your primary PVC and a replica running on a different node and a different AZ in your AKS cluster. So that's as easy as configuring storage classes. You don't have to worry about creating CSI plugins or anything like that. You have that solution ready to go. As you can see, if I do a get storage class, I see a few AKS or Azure storage classes available, a few default storage classes that Portworx created, and the custom ones that we just created right now. We'll now use a simple demo application that one of my teammates has built. Portworx Barbecue, a fun little e-commerce or a barbecue demo application where it runs as containers and uses a MongoDB instance running as a container on AKS as well to store all the user information and all the order history information as well in different MongoDB collections. So let's register for a new user. I'm just calling it demo user, being really creative with my username. And then let's just place some order, right? And another benefit of having a recorded demo, I can speed up through these things. I just want to make sure I have some data to protect or to show. So now we have some data in our MongoDB database. Let's inspect the MongoDB persistent volume, right? And I'll take a minute and actually pause this video for a minute. So The MongoDB container uses a persistent volume that's backed by Portworx, and this is where the value of Portworx comes in, right? You can see the different parameters that are being set for that persistent volume. This includes things like the status, the device path, all the different labels that you have attached, the read and write IOPS and latency that you see. But more importantly, it shows you where the replicas are spread out. In our case, it's simple, right? It was just a 3-node cluster. But for customer environments, when people are dealing with tens or hundreds of cluster nodes in a single AKS cluster, having this information helps them figure out, like, if they want to have a maintenance window, or if they want to do a rolling upgrade of their AKS version, they can identify where my different persistent volumes and their replicas are, maybe spread it out across AZs, and then take nodes offline one at a time and perform those upgrade operations. So Portworx spreads these replicas out by default using the labels that AKS uses for different AZs. And then it also shows you the amount of storage that you have actively used. I only have one entry in my BBQ app, so it's like 5 megs, but it also shows you the consumer. So it's that MongoDB pod that's running in the PX BBQ namespace. So that's how Portworx makes provisioning volumes easy inside AKS. Next, let's talk about snapshots. And we will cover 2 different types of snapshots in this demo. The first one being a single volume snapshot, right? Like, I have a MongoDB persistent volume claim. I want to make sure I protect it. I have a snapshot available on my same cluster. So it's a simple YAML file with a custom resource called volume snapshot that I can deploy and execute against my AKS cluster. And once I have a snapshot available, let's just drop the database, right? So the order that I just placed, if I refresh the page, that goes away. Obviously, we don't want this. We don't want to lose any user information or user data. We'll perform a restore operation, create a new persistent volume from the snapshot that we just created, and then just redeploy the MongoDB pod so that it can talk to the new persistent volume. The front end automatically connects to my MongoDB instance, and I have all of my orders ready to go. So if I refresh this page, my cauliflower steaks that I had ordered are still there, so I'm good. I know it's lunchtime for me, so I'm happy. So that's how a single volume snapshot works inside Portworx, right? Super easy. You create snapshots using YAML files, and for this demo, what we did was it was local to AKS. I can also push it out to an blob storage, as I already said. But instead of creating a one-off a snapshot, I could have configured a snapshot schedule inside my storage class definition. So whenever it hit that interval, Portworx will automatically take a snapshot. So let's say I want to take a snapshot every 15 minutes. I can enforce that or set that policy inside my storage class definition. So all the different PVCs that get created automatically inherit that snapshot schedule and take snapshots frequently. And it can store it locally or push it out to blob storage as well. So now let's talk about Portworx Autopilot, right? The rule-based engine that helps me expand my persistent volume. Another custom resource we have called Autopilot rule. And in this case, we are resizing a specific volume that matches the PVC itself will match the label app equal to Postgres. And then the namespace that it's running in will match the label type equal to DB. Having these 2 selectors helps you customize and spread out your or have individual autopilot rules for different resources for different applications. Once that's done, next thing you can configure is a condition. So the condition that should be met before Portworx performs a specific action for you. So in this case, since this is a demo, we're like, if my volume gets more than 20% full, which is not what we want to do realistically, but even if it's 20% more than 20% full, perform an action for me. And the action in this case is just scale the persistent volume by 20%. So we'll start in this demo. What we'll do is we'll start with a 10 gig Postgres volume. And then once it crosses the 2 gig mark, we'll automatically expand it by 20%. So the end result will be like a 12 gig persistent volume. So now let's apply this autopilot rule against our AKS cluster. And as we said before, this can be applied to different namespaces, different label-based objects as well. And now let's deploy the namespace with that specific label. Let's deploy the PVCs for our Postgres instance and our PG Bench instance, and then actually deploy the Postgres pods and PG Bench, Postgres pod with the PG Bench container as well. So as you can see, we have our PG Bench pod running. We have the persistent volumes. We're writing data to it, or PG Bench is writing data to it. And I can just do a watch on the events, the autopilot events. So all the rules will always be in normal state once you have applied it. and it will continuously monitor your utilization. Once we cross that 20% threshold, in our case, it gets triggered. And then once it's triggered, it goes to like performing specific actions. So it goes from active actions in pending to in progress to taken. So the persistent volume that started with 10 gigs in size is now 12 gigs without the user having to manually edit the running PVC object and making any changes. So this is where Portworx Autopilot can help you simplify your storage capacity management if you're running databases or data on Kubernetes. So finally, let's talk about group volume snapshots. I know I should have spoken about group volume snapshots with Snapshot, but I was just excited about Autopilot. So group volume snapshots are really tricky, right? When you're running, like I'll go back to my Cassandra example. If you're running Cassandra on Kubernetes, you have to make sure that you take a snapshot of all the nodes at the same time. You can't have a few seconds of difference between when the snapshot gets executed. This is where Portworx helps you. And then even further, right? If you take that even further, you don't want your snapshots to be crash consistent. You want all of those data that you have sitting in the memory being flushed to disk before that snapshot is executed. So you want to actually quiesce your database for just a second before the snapshot can be taken, and then you can resume your database instance. Portworx gives you the ability to do all of these things inside AKS. So let's create a new storage class, because why not? Let's create a new namespace called MySQL, and then we look at the pre and post snapshot rule. So in this pre rule, again, it's a custom resource called a rule. And here what I'm telling it, like, okay, for the MySQL pod, which has a label of app colon MySQL, use this command to freeze or to quiesce my database. So flush tables with read lock, and that's my pre rule. I can have a similar rule for my post rule. So like once the snapshot is taken, I want to resume my MySQL instance as well. So let's look at what that configuration looks like. So in this case, flush logs, unlock tables, and my application can continue writing data. So this is how Portworx can ensure application consistent snapshots. Let's go ahead and apply this pre and post rules in my MySQL namespace that I've created. And then once that's done, we'll go ahead and create our MySQL pods and our actual application itself. So I'm deploying my MySQL app, which includes a secret, a service object, stateful set objects with persistent volume sitting behind it, and then a service instance as well. So we'll see how these things are quickly getting deployed. A read write once volume using group-sc Portworx storage class are getting dynamically provisioned. 2 gigs in size. We just wanted to keep it small for this demo. So once my MySQL cluster is up and running, or my master and read replicas are up and running, I can go ahead and exec into the MySQL container and create a new database instance, create a new table inside my MySQL database, and before we take that group snapshot. So let's log in. We'll just create a table called Portworx and a database called Portworx and a table called features. Added some rows to it with 3 different columns. So now we have data in our MySQL instance. Now let's talk about a group volume snapshot. So this is where everything comes together, right? I'm creating a group volume snapshot object. I'm telling it, this is the pre-exec rule that you should take. This is the post-exec rule that you should execute. And then these are the labels that you should match for when you're taking this group snapshot. So it basically takes all this 3 PVCs that we have in our MySQL namespace. So let's apply this configuration, or apply this group volume snapshot object against our MySQL namespace. And then just takes a few seconds. We'll do a describe, and you can see that all 3 snapshots were taken at the exact timestamp of 2014-45. I don't know when I was creating this, but it is 2014-45 for all 3 different PVCs and the snapshots that exist for them. And we executed the pre and post snapshot rules as well. Now let's log in or exec into our MySQL database and basically delete the features table or drop the database Portworx that we created. And now let's see if we can restore this actual database, right? So to restore, what we'll do is we'll create 3 different PVCs from the 3 snapshots that we have available. For this, I'm just using a bunch of bash commands and fetching the volume snapshot ID. And then I am going to dump it all into like a new YAML file. So these are the 3 different snapshot IDs for 3 different persistent volumes that I had. And I'll just create a new YAML file and apply that YAML file, which creates these new persistent volume objects. So let's show you what it looks like. 3 PVCs, in the same, like we'll apply it in the MySQL namespace, same size, or we can actually update the size as well if we want to. And then let's go ahead and apply this YAML file in a MySQL namespace. So this creates these 3 PVCs from the snapshots that we have. As you can see, the PVCs are all up and running. Now I can redeploy my MySQL pods. And since my data was persisted across the deletion and everything that I did to my front end, like the MySQL pods, if I exec into the MySQL pod again, I can verify that the Portworx database exists and the features table exists as well. So let's do that, right? Let's exec into the MySQL client pod again, and then just do a use Portworx database, and then look at the features table. So again, as we see, like all of our the entire table with all the rows, all the columns is now back up and running. We didn't lose anything. This is how you can use Portworx group volume snapshots as well. And this became a marketing slide. Then we go back to my slides. I just have a couple more slides talking about how you can get started, right? If you like this demo or the slides that we did, if you wanted to get started, just go to central.portworx.com. You can use a Portworx Essentials license, which is a free forever version with some with limited capabilities. It doesn't have the DR and additional things that you need, but it's good enough to run a 5-node AKS cluster, a 5-worker node AKS cluster, and get Portworx up and running. If you wanted the full-fledged Portworx deployment, that does have a free trial for 30 days called Portworx Enterprise. You can generate a configuration for the operator and the storage cluster custom resource from central.portworx.com as well. And then if you wanted to try out our data protection product, you don't need Portworx Enterprise. You can just try it out with just the Azure storage classes that exist. So you can either do a self-managed one with Portworx Backup and a free 30-day trial, or we also have like a backup as a service offering where you can create a service instance. We host the control plane for you. You can just connect your AKS clusters and start creating backup jobs. And as long as you don't, or you keep your application data under a terabyte, you can keep using this for free forever. So that's a freemium offering we have as well. But if you wanted to take the next step, right, I just want to deploy this on my AKS cluster today. Portworx, Pure Storage, and Microsoft have worked together, and now Portworx Enterprise is listed on the Azure Container Marketplace. So just go to your Azure portal, search for Portworx Enterprise or just Portworx. Entry shows up, select your subscription, and then just you can create a new subscription or a new entry for it. And that's how easy using Portworx and getting started with Portworx is. Hopefully, Brian, this was helpful to your listeners, and maybe we learned something new today.
Yeah, I think it was. Yeah, in fact, it was funny. I was just about to, at the very end, ask you the question about the marketplace, which I was pretty sure it was. I actually went and looked around and saw it in there. But yeah, that's good to know. That was actually asked in the chat. So good to have that. Yeah, I enjoyed the demo. It was funny. I kept forgetting that it was recorded. I was like, you restored the table. I was like, yes, the table restored. But I get it. It was recorded.
Yeah.
I'm a big fan of a live demo, but there's just too many moving parts. You're relying on cloud service. There's so many things that could go wrong, and I thought
this is the first time you invited me, so I came in with the recorded one. If I get a repeat invitation, I will I promise I'll bring a live demo next time, Brian.
Yeah, absolutely. No, I thought it was a great overview of the technology. Got a good understanding of kind of how things worked. As we had talked about before, I felt like you would get this question, and so I'm going to put this up and have us both kind of talk to it. Gets this one here. Yeah, so obviously, folks on this call, they're passionate about AKS and Azure, and so not surprisingly, we had recently announced this Azure Container Storage. People are trying to understand it. I'll let you talk too. The only thing I would say about it is we try to have a breadth of offerings for our customers. Customers come to Azure and they have all kinds of different sort of requirements. And so in my view, we have to have native solutions in Azure. Some customers are always pushing, hey, what do you have natively built in? Whereas many customers have other kinds of requirements and are met by Portworx and many of our partners. And we love all of those customers and we want them kind of all to be successful. So I don't know, you had thoughts on that, but I think we love everybody.
Yeah, and we love all of our partners as well, right? Talking about the second part of the question, maybe Azure Container Storage uses Portworx behind the scene. I don't think so, but Portworx integrates with Azure by integrating into the Azure API. So like whenever you deploy Portworx Enterprise, you don't have to worry about manually deploying Azure disks and mounting them to your AKS worker nodes. All of that is automated for you. So as soon as you apply the custom resource using a YAML file, we'll automate all of that and give you a storage cluster that's ready to use.
Yep. And someone commented in the chat, Tim Darnell said, Azure Container Storage based on Open EBS, which is correct. Yeah. So, but yeah, valid question. And yeah, I think it's a good topic to kind of talk through.
Yeah, thank you, Tim.
Yeah.
Tim is actually my manager, so I'm glad he's on.
Perfect. Oh, I didn't mean to show that question. So yeah, the other thing, I mean, if anybody else has kind of other questions, certainly please do chime in. Something I'm always curious about, it's been hard over the years with Windows containers, and I'm always asked about this. And I've struggled a bit with Windows, but there's a huge demand for building Kubernetes clusters on Windows, and the support is there. We certainly support it in AKS. And ever since we made it a full-fledged citizen in our platform, it just continues to grow and grow and grow. And so, yeah, can we use Windows? Because often the answer is maybe or no. So.
No, that's a great question, right? And we see the same thing. Like more and more people are asking for Windows container support, and they want to run stateful apps on their Windows container or using Windows containers. The Windows container support is not GA yet, but we are working on it. Comes out in a couple of months. We're working with a couple of financial institutions to design the actual offering. But yeah, I guess maybe we can do a repeat live stream when we have Windows container support.
Yeah, I think Windows
it's coming for sure to answer your question. Sorry.
Yeah, good, awesome. Yeah, and I think Windows certainly is a topic we may just do a very specific talk on this channel at some point for sure. The other thing that I constantly hear in this space, and sometimes the word cloud native gets thrown around in everything, and we just hear cloud native. But when people say cloud native storage, is that the same as kind of using these CSI plugins? And kind of explain the difference there, because I think that's common confusion here that I hear.
Yeah, for sure. So like CSI plugins, right? Like cloud native storage, Portworx is a cloud native storage solution. And what I mean by that is it runs on your Kubernetes cluster itself, completely software defined. We don't have dependency on any hardware solution or any cloud storage solution. You can run us on bare metal nodes, on-prem, virtual machines, in the cloud, wherever you want to run Kubernetes. And then the difference that I see between CNS and CSI or CSI-based plugin is vendors like even Pure Storage, before they acquired Portworx in 2020, had a CSI plugin that made it easier for people who wanted to use Kubernetes but didn't want to build something of their own, use their existing investments in their storage platforms and use the existing storage arrays that they already have. So you'll see vendors like Pure Storage, NetApp, Dell EMC have CSI plugins that make it easier to consume. But again, those arrays were not built for Kubernetes, right? They were built for virtual machines. They were built for mounting LUNs on and attaching them to your bare metal node. So there's that difference. Like cloud native storage is more Kubernetes native, built for Kubernetes.
Yeah. Cool. Makes sense.
Yeah. Thank you.
Well, it doesn't look like we have other questions in the chat. I bet we'll get more when people catch the recording. So we'll both kind of keep our eye on that. If anybody's watching, put questions in there. We watch them. We make sure that we're looking for that kind of thing and answering them. But with that, I'm going to go ahead and wrap up. Again, Bhavin, I'll say thank you. I thought it was a perfect kind of session. That's exactly what I'm looking for. I appreciate you being here and talking about Portworx on AKS. So enjoy the rest of your day. And yeah, thanks again.
Thank you so much, Brian. And I know I said this before we started recording or went live. Love the cap. Like, that's awesome.
Right. There's a point where people are like, oh, what hat is he going to wear? Now I have to live up to something. Sometimes it's just a plain old hat, but yeah, I'll try to keep the hat.
No, every 2 weeks when you're doing live stream, right? I think repeat listeners will be like, okay, what's the cap that Brian will wear today?
Right. Yeah, a lot of pressure. I'll have to keep up. Yeah. All right, cool. Awesome. Thanks again. Thanks everybody for listening. Have a good day.